Hey guys, welcome back to our series of system design sessions. In this session today we are going to talk about networking protocols. We'll basically touch down upon a lot of networking on how does the packet flow from a client to a server and what all protocol stack comes into picture, right? So just a quick review first of all on what we have covered so far. So in the last few sessions we have been talking a lot about how do the client and the server talk to each other. So we discussed that every particular communication which is happening over internet, whenever two entities are involved, one of them is actually a client and the other one is a server, right? So there is one more model apart from this, which was peer-to-peer, which we will discuss in the later sessions. But for all other models wherein we are getting a website, we are filling up a form, we are getting an API call, for all of them, the client-server architecture comes into picture. Right. So basically we saw how does a client sends a request to a server and how does the server returns back the response. Right. So we mainly saw the request and response models and what all actually happens at the client and the server side whenever we send a response. Okay. So we have covered this part, we have covered this part, but in today's session we are going to cover the protocols which will come into picture when this communication is happening. Okay, so what do I mean by this communication? I basically mean by this part of how does the packet, suppose if I'm sending some data to the server, how does this data travels all the way to the server and then server responds back in the similar way, right? So in this session, like we are going to talk and call it a packet just to get comfortable with the nomenclature. We will use this nomenclature a lot. A packet is basically just it's just a collective units of multiple bits which have been following some kind of protocol and which are encapsulated together with some headers. It's more like a data which is traveling from a client to a server and from a server back to the client, right? So we saw this model and we also discussed a little bit about DNS on how do IP works. We saw like every particular node in the internet will be assigned some IP. So suppose this is having IP1, this will have IP2, and all other nodes will also follow the same convention, right? So now to talk about this particular thing on what happens with this packet and how does it flows back to the server, right? So let us suppose I'm sitting in India right now and I'm trying to reach a server which is located in US. So how does this packet flow all the way to the US and then comes back with the response? And the most amazing part is it comes back within milliseconds, right? So that's what we are going to see on how do we get such a quick response back from the server even if we are sending a packet to, let's suppose, 3000 4000 kilometers away from my current location, right? So to understand this, let's touch upon a little bit upon networking first. So in networking we are going to talk about TCP IP stack. Okay, although there are multiple stacks which are like actually existing in the networking protocols, but we will mainly look at TCP IP stack. There is also OSI stack, which we will discuss towards the end. It's nothing like OSI model, just an adopted version of TCP IP stack only. In TCP IP stack, we have multiple layers, right? So what are these layers? The first layer is application layer. The second layer, which we talk about, is transport layer. The third layer, which we talk about, is network layer. The fourth layer, which we talk about, is link layer. And the last one is the physical layer. Okay, again, these are just like, this is just theory, hypothetical scenarios. Whenever a packet travels from this part to this part, from client to server, we actually have divided the journey of a packet into 5 multiple layers. You can treat it this way, right? Application layer, transport layer, network layer, link layer, and physical layer. Although these are very sophisticated terms and you will see a lot of jargon which comes into each of these layers when we talk about them. So just to like make our discussion easier today, we will take an analogy of a post office, right? So we will see how does a letter travels from a client all the way to the server, and we will take the analogy of a post office. One more interesting thing here is, if you are treating this particular stack in terms of a post office, suppose the basic entity which is traveling across client and server is a letter, right? So if the basic entity is a letter, and by letter I basically means data, so if letter is traveling across client and server, each of these layers will actually add up a separate envelope on top of the letter, right? So here's my letter which is having some amount of data. First of all, when it go to application layer, it will add up some envelope. Transport layer will also add up some envelope, right? All of these envelopes get added up, and at the server end, server will actually one by one remove all the wrappers or all the envelopes, right? So this is how it happens. Client will keep on encapsulating the data or the letter in multiple envelopes according to these layers, the logic of these layers. And at the server end, we will decapsulate, right? We will remove the envelope one by one and see what's inside, right? So let's start our discussion here. So let us suppose this is my client and this is my server, and the client wants to send a letter to server, right? So here the client wants to send a letter to server. Now the most important thing here is we are treating like our letter is basically nothing. It's just a request which you are sending. But we are taking analogy of a letter, not a request, because then it will get a lot more technical, right? So what does the letter contains? First of all, so a letter is nothing. Letter is something like, okay, let's suppose the server which we are reaching is Demux server. So letter is nothing. Letter just says, hey Demux, can you give me your web page? That's it, right? But in a letter there will be multiple elements. Okay, so what are these elements? So first let's talk about the request. So the request would be something like get demux.in. Then there should be some cookies along with the request. Now what is the cookies? Cookies are just some memories which the server earlier had on the client, right? We will talk in detail about cookies. In fact, cookies is one of the most important element, and the whole marketing industry is working right now on cookies only. But for now, you can just understand it as an ID or some amount of data which the server has stored over the client. Okay, so I'll just write down some memories here from the server. Then there will be some data like I am Chrome. So this will be my browser, or basically my client from which I'm sending the request. Then there will be some amount of data validation like I accept HTML. This will be the return type for the server. So this client is telling the server, okay, I can read HTML, you can send me back the response in HTML format. And then there are multiple other factors as well, like whether the compression of the data is allowed at the client level or not, or what is the port number of the request which is going on, and etc. Okay, so this all will be my letter. This all will be present in my letter or my request which is going from my client to the server, right? So just a couple of clarification here. When I talk about client, I'm talking about my browser, right? And when I talk about server, I'm talking about the application which is running on the server, which is giving back the response, right? So till now we have the letter, and the client has created this request, my browser has created this request. Next, what will happen? The letter will go to the operating system. Okay, so the browser will tell operating system, okay, here is my letter, can you please deliver it to this website? Okay, let's suppose the letter is there and the browser wants to deliver this letter to www.demux.in. Okay, now this information my browser will pass on to the operating system. And what operating system do here is, operating system first of all take up this information, okay, take up this information, the letter which is the request as well as the URL on which we want to hit, and it will basically divide this letter into multiple parts. Why it will divide into multiple parts? Because the letter could be huge as well, right? There could be a lot of data which is present inside letter. So operating system, for making it compatible enough for the lower layers, it will break down this letter into multiple parts. So if operating system is receiving L from a browser, it will divide into L1, L2, L3, L4 and so on. Each of them will again have all this information, but the data will be divided, right? So this is what my operating system do. And then operating system will also get the IP corresponding to this www.demux.in, right? How do we get the IP? Again, very simple. Last time we discussed, the operating system will be calling something known as DNS, domain name server, which will keep mapping of all the domain name is to IP. If you don't know about DNS, you can go watch the previous video. Therein we have discussed in detail about DNS, right? So once operating system will call DNS, it will get the corresponding IP. So this will be my destination IP now. Okay, so far my operating system will have a letter which it has divided into multiple chunks, L1, L2, L3, L4, and it has the destination IP. at which the operating system needs to deliver these letters. Okay, there is another interesting factor here, which is the operating system will also gives back something known as a socket to the browser, right? So operating system, let me just get the color pen here. So operating system will give something known as a socket to the browser. Now what is a socket? We will try to discuss socket in the later upcoming part, but for now you can think of a socket as a mail bin. Okay, so operating system will tell browser, okay, I have your letter, I have your destination IP, and here's the mail bin. Mail bin is just a location wherein the browser needs to check whenever the response comes back from the server, right? Think of it as a mail bin, right? Simple enough. So the operating system will actually push the response whenever it gets the response from the server, and it will push it inside this socket or the mail bin. Okay, so now operating system have this request. Now what will happen? The next thing which is going to happen with my letter, let us suppose I have this letter here, let's call it L, and L basically I mean the chunk only, like one of the L1, L2, L3, L4 is what I'm taking as a L here. So once the operating system gets the letter, it will get the IP, right? Once I will get the IP, the operating system will actually start routing the letter. So then my letter will actually go through multiple routers. Okay, now what actually is the router? Think of a router as just another post office, right? So a router is it's basically more like a conveyor belt wherein a lot of shipments of lot of letters are coming in, and then my router is actually forwarding them to multiple locations. Okay, although the router does not know where exactly it needs to deliver the letter. Okay, but it has this information. Okay, I have, if the router has the destination address, it will have this information like which particular router it needs to forward this particular letter in order to move this letter to its destination. Okay, think of it as a chain of post offices, right? So suppose if I'm sending a letter from Bangalore to Lucknow, so if it goes to the Bangalore sortation unit, basically the post office, then that post office will not know where Lucknow is located, right? But the post office will have this information that Lucknow is somewhere in UP, right? So the post office will redirect that letter to the UP's main post office, and then UP's main post office will redirect this letter to Lucknow area, and then Lucknow area post office will probably send it to some other area like Hazratganj or some sub area of within the Lucknow locality, right? So that's how the router also works. Okay, so once we get the letter to the router, a router will forward the letter to another router. This another router will again forward the letter to some other router, and then it will keep on going until and unless we reach the destination IP, or basically the destination server. Okay, so think of it as a web only, like a spider web only, wherein multiple routers are talking to each other, and each of them will have a forwarding table. So this forwarding table will help identify the router to which location does it needs to forward the letter. So all these L1, L2, L3 are basically pushed upon this conveyor belt, and they will be consumed by this router, and then each of them will be forwarded to a different direction. Now, since they are all going to a same destination server, they will all go into the same direction, but in multiple letters cases, it can go to different locations, right? So once we have this, the router will start forwarding this letter. It will go to R2, R2 will forward it to R3, and with this only, it will somehow reach the destination state. We'll come back on this part later on what actually is happening behind this router here. But let us look at some of the problems which are associated with this forwarding thing, right? So one of the problems here is, and a very major problem here is, first of all, congestion. Okay, so since there is a lot of traffic on the router, it could be possible that one of my chunk, let's suppose L3, get lost. If L3 gets lost and L1, L2 and L4 are reaching my destination server will not be able to identify the request, right? Remember in the last slide, we speak about that the entire letter has been divided into L1, L2, L3 and L4. So if L3 is missing, the definition of L will not be complete, right? So my server will not be able to identify that what actually is the request, because my destination server will only get L1, L2 and L4. So this is a very huge fallback, because if one of the packet get lost, then the server will not be able to identify the request, right? So generally, to tackle this problem, we need something known as a reliable system. Okay, what kind of reliable system? In very simple terms, a system which will tell back my client, suppose this router only, which will tell back my client, okay, you have sent 4 packets, but one of them is lost. Could you please send it again? As simple as that. Okay, so we need this kind of system wherein the client, which is my operating system or my browser, will get this notification whenever a packet gets lost. Okay, now to build up this reliable system, the people who were designing the internet or the entire networking stack, they came up with another layer. What is this layer known as? This is known as transport layer. Okay, so the transport layer is something which actually provides us reliability. Reliability in terms of the fact that my letter will be delivered to the destination server. No matter what, all the chunks will get delivered in the correct order to the destination server. Right? So the destination server, now if you see this IP, whenever we are getting the IP, we were in network layer. But now we know something, that we also need to involve transport layer. So first of all, what we need to do, the letter will need to encapsulate itself into the transport envelope. Right, so this is my letter here, which has all the request details which I mentioned earlier, and now it will be encapsulated into the transport envelope. Now there are two different kind of transport protocols which we follow. First one is the TCP and the second one is UDP. Okay, let's look at the first one only, because that's the one which actually provides reliability. So how does the transport layer provides reliability, right? If you remember in the last slide, we have this problem that if one of the letters or one of the chunks of the letter get lost, we will not be able to get to the destination server, and destination server will not understand the entire request, right? So how do TCP make sure this reliability is actually like present in the system? So for this, TCP platform, actually TCP servers do a handshake with the server. This process is known as handshake. Now, what is a handshake? A handshake is nothing. It's just a kind of some information which is passing between the client and my server before we start sending the request. Okay, so what happens is, suppose if I have my client here and if I have my server here, in TCP will first of all send a dummy request to the server. Okay, the server will respond back saying, okay, I can hear you. So this could be simple like, okay, client will send, can you hear me? The server will say, yes, I can hear you. Right? But now there is a problem. My client will know that server can hear me, right? But the server will not know whether the client can hear me or not. So there is the third call which happens, wherein the client will also tell server, okay, yes, I can hear you. So this process is known as handshake, although like, I know like the way I have explained this is very simple enough, but there is a lot of data which gets transferred, and all of this definitely is not going to happen like this. Yes, I can hear you. No, you can hear me or not. This is actually some data which is sending between client and server, data in form of bits and pieces, and then the client and server gets to know, okay, each of them can hear them. Okay, but this process is known as three-way handshake, and through this process, the TCP, which will initiate us as a communication with the server, will now provide reliability. Okay, so what will happen after my request will get encapsulated into a transport envelope? The request will then start sending to the destination IP. It will start reaching the destination IP. The same process will follow. It will go through multiple set of routers, and each of the router will be forwarding it to multiple locations. Okay, now there is another router here which is again doing similar thing, and will definitely at the end reach the destination. So what will happen here is, the client and the destination, since both of them are working upon transport protocol, each of them will actually keep sharing some messages. Okay, what are these messages? This message could be so client and server will keep sending each of them messages. Messages could be, I've got 100 packets till now, something like this. Okay, so the server will tell client, okay, I've got 100 packets till now. So this way, the client will identify, okay, you got 100 packets, but I sent 102 packets. So where are rest of the 2 packets? So the client will immediately know, okay, 2 of the packets get lost in a network congestion, and now I need to relay those 2 packets. Okay, so through this communication, the client and server are making sure that none of the packets are getting lost. And even if they are getting lost, we are re-relaying the packets, right? So the the role of transport layer here is to provide this kind of reliability between the client and the server, such that the request will keep on flowing, and even like both of them will know if there is some error with the network. Right. So that's about TCP. But if you see, there is one problem with TCP. What is that problem? The problem here is, since we are doing a lot of pre-processing here, right? We are doing a lot of pre-processing in terms of, first of all, the client will talk to server, send out 3 requests. And even then, if one of the packets gets lost, it has to send all the packets again. Suppose if 56 packets get lost, then it has to send 56, 57, 58 up to 100 packet again. Right? So it will take a lot of overhead, right? It will take a lot of time. Now think of some of the services like Hotstar, right? Or probably you are watching a movie on Netflix, or probably some cricket match which is streaming live. So in these kind of real events, we cannot afford this much of lag, right? If the client and server will keep on talking to each other, sending packets again and again, then probably we'll miss out the match, right? So in these kind of scenarios wherein some real-time service is going on, and we can afford some kind of like some kind of data lost here, like basically if some of the packets are getting lost, we can afford it, right? So in these kind of services, streaming services, we use a different kind of protocol which is known as UDP, which is user data count protocol. Okay, it is also known as unreliable data protocol, but yeah, some people call it, but it is user data count protocol, wherein this thing does not happen, this cross-checking thing does not happen, and we just send the packet one by one. We don't care about whether the packets are reaching to the server or not, right? If you see when you do a Skype call, or whether when you are on Zoom, there could be some lag, right? And that lag is present mainly because of UDP. Because we are using UDP, there is some lag in the video, but we can afford it. We don't care about whether there is a small lag or not. The only thing we are concerned about it, whether we are getting real-time response or not, whether we are getting the live match with a like probably 5 milliseconds, 10 milliseconds delay or not. Okay, we cannot afford a 10-minute delay in the cricket match. Like that will not be like good enough for us. Okay, so for this one thing, we have UDP here, and UDP is again like we don't do all this reliability check. UDP makes sure we are sending packet one by one. It does not care whether the packets are reaching to the destination or not. The only job of UDP is to just relay the packet. So UDP just blindly relay the packets all the way to the destination, and destination will get the packet, and then it will process back the response. Okay, so that's about TCP, UDP, and the transport layer. There is one more important thing here in transport layer, because whenever we are packaging here, it adds one more detail in this envelope. What is this detail? This detail is known as port number. This detail gets added by transport layer. Now, what is the port number, right? Let us try to understand port number in a very simplified manner. Let us suppose that you are in your house, right? You're sitting in your house, and there is someone who wants to send you a letter. Now, I'm not talking about what kind of letter, you might be guessing it by now. So if there is someone who wants to send you a letter, and in your house there are multiple people, like you are there, your sister is there, your father is there, your mother is there, and you don't want anyone to take up this letter. Obviously, like if it is coming from someone special, you only want to take up the letter, you don't want anyone else to read the letter, right? So what will you do, right? So the most simple way of solving this problem would be to add up a post pin outside the house. Okay, in this post pin, you are making sure like all the letters which are addressed to your father will come here, all the letters which are addressed to your mother will come here, all the letters which are addressed to your sister is here, and all the letters which are addressed to you are here in this portion. And each of you will have a key or basically something to unlock this pin, right? So this way we can make sure that if the letter is coming to you, I am the one who is getting this letter and not anyone else. No one can read this letter, only I can read this letter, right? And that's the basic analogy behind port number. So port number are generally the gateways which are present inside every machine. Every server, every client, there are some gateways through which it can talk to the outside world, right? So think of a server here. Now server will have multiple services running on top of it, right? Like most simple one, there could be application server, application which is running there. There is some other application known as FTP which is running, which is file transfer protocol. Then there is a database server which is also listening to some other port number. So server is also listening, like on the server side also there are multiple things which are listening, right? Remember in the last slide we discussed about destination. How do I basically identify the destination? Through IP only, right? Now I know the IP of the destination server, but I don't know the process through which I want to communicate, right? On a server itself there are multiple processes. One process is giving me the website, the other process is taking up my Google Forms and submitting it, the other process could be giving me a download of a file. So there are multiple processes which are running on the destination side, and in order to identify those processes we have something known as port number, right? So port number will tell me which process I need to talk to on the server side, right? Now with this definition, like port numbers, there are two, like whenever the client gives the request to my operating system will talk to transport layer, and transport layer will actually add up a port number here. Now this port number will be directly connected to the socket. Remember the socket? We talked about socket in the very first slide. We spoke like socket is more like a mail bin which the operating system provides to the client. Let us talk in detail about socket now. I think we are in good positioning now. So a socket is more like an interface which has been provided by the operating system. Okay, think of a socket as an interface. Okay, what is the interface? It's more like a file. It's more like a specific directory or a specific file which the operating system has provided to my client, which in this case is my browser, and it is telling the client, okay, if you want to send a request, every request will be directly attached to a socket. Every request which I am sending to the server will have a separate socket. Right now, socket can be identified by multiple factors. Mainly there are four factors which could be used in order to identify a socket: destination IP, destination port, source IP, and source port. These are the four different things which actually creates a unique socket. Okay. Now I believe a lot of you are doing lead code these days, right? So and like many time when we do lead code, we open up multiple tabs, right? There is one discussion forum, there is one question, then there is solution, then we also want to read about other things on lead code, right? So there are at a time there are close to 7-8 tabs which are opening in a browser, right? So have you ever thought like how those tabs are working? Because they all are talking to the same website, which is leadcode.com. Right? So this is happening through socket, because if you see, there is one entity out of this port which will be different for every socket. There is one entity which will be different for each of the socket. What is that entity? That entity will be source port. So the source port will be different for every Chrome tab which you are opening, which you have opened for lead code. Right? Although the destination port could be same, it could be different depending upon lead code, but the source port is definitely going to be different, because every particular tab which you have opened in your browser you will have multiple tabs, right, on leadcode.com. So every particular tab will have a different source port, because we just discussed that every request will have a unique socket. So every particular tab will have a source port, a different source port, and thus every particular tab will be working independently. And that's the reason why multiple tabs will work in parallel, although they are talking to the same web server, right? It's the socket which actually brings differentiation. It's the socket which helps these multiple tabs to work in parallel, right? Each of the tab will be working on their own. They must be loading some amount of code. They must be loading some amount of JavaScript, some amount of script which is loading there. But each of them is happening through a separate code, separate socket. So the operating system on my browser does not care much, because for them it's a different socket altogether. My browser does not understand whether I'm talking to LeetCode or whether I'm talking to InterviewBit or whether I'm talking to Geeks for Geeks, right? My browser only understands that I'm talking to a particular socket, because that's where my browser is listening to the response, right? So this socket is the thing which help us uniquely identify a particular tab, although even when we are talking to surfing different website in different browsers, sorry, different tabs of the same browser, right? So that's the basically the logic behind having different port numbers, and every particular socket will have a different port number, source port number, right? So till now what we have done, let me just like write down what we have done. So till now we have seen my browser will be here. My browser will be sending the request, which in our case is a letter, to my operating system. My operating system will be dividing this request into multiple parts: request 1, request 2, request 3, and request 4, and then it will move on to the transport layer, right? So there will be the transport layer here. Let us suppose there is a transport layer. What will transport layer do? It will actually add up a separate envelope on each of these requests. So there will be R1, R2, R3, R4. Each of them, let's suppose, is a letter. So the transport layer will add up a separate envelope on each of them. Right? Now, once transport layer adds up this envelope, it will be passed on to the network layer. What is network layer? We spoke about network layer just in the beginning, if you remember. Here is the network layer, wherein we get the IP. Once we get the IP address, the packets start moving into towards the destination server, right? So then after transport layer, there is another envelope which gets added up here, which is known as network header, or basically network envelope. Right, so the outer one is the network envelope, and the inner one here is basically my transport envelope. And like this is my letter, which is my request again. Okay, what does my request consist? As I told you just in the beginning, the request will be consisting these data, this amount of data, wherein we have a lot of things which are coming into the request. Right. So once we have this information, so far what we have done, we got the letter here. So transport layer also add up the port number here, and network envelope will actually have the IP address. So once we get this information, each of these packets will actually start moving in towards the router. Okay, and that's where it will enter the link layer, right? So the link layer starts whenever we have the packet ready up to network envelope, and then it start transmitting these requests onto the routers or the sockets. Okay, so the link layer, basically the basic functionality of link layer would be to move or forward this letter from one router to another, and probably like give it some kind of direction on where it needs to move. So after this, it will move on to link layer. Let me add up link layer as well. So this will be, let's suppose, my network layer. So next will be my link layer, wherein a separate header will get added here again. So link layer will also add up an envelope on top of the existing one. So lot of things which are going on here: transport, then there is network, and then there is a link layer envelope which gets added. Like, what does link layer do? It generally just add up a separate information. So when I talk about envelope, each of them are adding some information into the metadata, more like a metadata information which they are adding into the request, right? Now when it gets encapsulated here and it moves through router to router, let us see like how do the internet generally works in our house, right? So when I'm sitting here, let's suppose I'm sitting in my house, I'm surfing some kind of website. What will happen? I will first of all this thing will happen. Let us suppose this is my computer, which I have like written as my house here. Okay, let's suppose this is my computer. And what will happen when I create the request will go talk to operating system will give it to transport layer, which by the way is present at the network interface only, and then it will give it to network layer, which is again until the network layer, that request is present within my computer only, right? After which it will start moving outside. So first of all, it will go talk to something known as ISP. Right, now what is the ISP? Internet service provider, as we all know about it. So what does it do? Internet service provider basically help me move on to bigger ISPs, right? There are multiple ISP and different hierarchy of ISPs which are present, In most simple terms, like first it will go to my Wi-Fi device. If I'm using Wi-Fi here, go to the Wi-Fi device. Wi-Fi device will reroute the packet to ISP. ISP will probably give it to some other ISP, and then it will move, like it will enter uh, the web of routers, right? So it will move from router to router. So router or basically link layer switches are two different devices which are present on the network layer, and they help us transfer the, like they help us in forwarding the letter. So they both of them have a forwarding table. Forwarding table could be something like this, as like in most simple terms, a forwarding table which router will consist something like this. Like there will be some kind of header which the network layer adds up on the packet, right? So it could be, if the header is 1 to 10, send it to R1. If header is 2 to 11 to 20, send it to R2. This is the kind of forwarding table which every router will have. Okay, now forwarding table could be different as well. There could be dynamic forwarding table wherein the router is learning on the way, or there could be static forwarding table. So the router do nothing, they learn nothing, they just forward the packet as per the configuration which has been done in the router, right? So router and link layer switches are two devices. Just like I told you, like in the very beginning, internet is created by multiple nodes. It is also one of the nodes, right? Only difference is they are not the end nodes here. They are some kind of communication devices which are helping my request go to the destination, right? So router and link layer switches will be, it's more like a web of router and link layer switches. ISP will move it to the router and will go through a web of router link layer switches until it reaches something known as optical fiber or optical cable. Okay, so optical cables are like, it's not necessary that it always go to the optical cable. It can even reach the destination without moving on to the optical cables. Optical cables are generally a very large mode of networking wherein, let's suppose I want to send a packet from Mumbai to Singapore, right? So there is an optical cable which is which has been installed right from Mumbai to Singapore, or there could be optical cable which has been installed from Chennai to Hong Kong, or Kolkata to Hong Kong, or let's suppose New York City to London. So the major hubs are connected through optical fibers, optical cables. They are the ones which actually transmit data, right? Large amount of data, and these switches and routers finally go and transfer the data to optical cables, and optical cable will then transfer the data to the destination. Now let us see how the thing will unfold. Let us suppose it will reach the destination. Okay, optical fiber will move it to the destination router. By destination router, I mean the router which is closest to my destination server, right? Once it reaches the destination router will give it to the server. Let us suppose my destination server. Let's try to see what will happen during the unfolding phase now. So I think I'll need a new slide for this purpose. So here's my destination router. And it will give the request to destination server. So what will happen here is, once it give it to destination router, somewhere here, first of all, it will remove the link layer switch. The first thing which will happen is remove the link layer switch. Not switch, actually, envelope. Then it will remove the network layer envelope. Now what data it will get out from network layer envelope? It will get the IP address, right? IP address and some other fields which are present in the network envelope. Then it will remove the transport envelope. What data it will get from transport envelope? It will get the data like which particular port number it needs to hit on the destination server, right? Destination server also will have multiple processes which are running. Let's suppose there's a Apache server which is running, there's a FTP server, there's a database server, there is some other thing which is running. So this will, the transport envelope will help me identify which port number of which particular application which is running on the destination server I want to hit. And thus it will give back the envelope or the letter to the destination application. Now, when you are doing web surfing, the destination envelope will be, application will be Apache only, which is Apache or Nginx, which is actually listening to all HTTP requests, HTTP or HTTPS. right? So this is how the letter, which is just a request, will flow all the way to the destination server. And this is how multiple layers, multiple segments will keep on adding to it, right? So if we go to the very first slide here, now we have listed down few protocols which we need to study, right? Application protocol. Let me just give you a brief overview again of what we need to do. Just one thing I think I forgot. So this was actually physical layer. When we are talking about the optical cables and a large portion of large high optical fibers, this will fall under the like of physical layer, right? Physical layer is when the data is actually getting transformed from multiple router to router, right? So that's the physical layer which do the actual transfer of data. This is the only thing which you can see. Actually, rest all protocols are somewhere hidden inside a computer or towards a network chip, right? So let's do a quick analysis of each of these protocols which are listed here. So if you see my application server, what is my application server doing? It is only concerned with the destination application, right? It is only concerned with destination application, and it wants to talk to the destination application. That's what my application layer wants to do. Next comes the transport layer. So my transport layer, the main role of transport layer here would be getting the packets delivered in the same order or providing some amount of reliability. I think there is less space here. We can probably take up a new slide. So first of all, we'll have the application server. The application server will do what? It will only be concerned about applications which are talking to each other. Okay, so the application will not have any know-how of the lower layers. Like it will not know whether link layer is coming into picture, network layer is coming into picture or not. Only thing which it cares about is it wants to talk to the destination application, which is Nginx or Apache in case of normal get calls or post calls, right? So the application layer would be concerned with talking to destination application. Okay, now comes the transport layer. So what my transport layer will do? Transport layer will, first of all, it will, like, the main thing it will provide is first of all reliability of data. Whether the data is getting sent to the destination server or not, which has been provided by TCP. Okay, the other thing which it does is getting the packets delivered in the same order. Okay, so if you remember here in this slide, we talk about how do the transport layer help me sends the packet in the same order, right? If one of the packets get lost, let's suppose I am sending 100 packets here. So if 50th packet gets lost and it will get this acknowledgement back from the server, then my client will again send 49th to 100 packet, right? 49, 50, 51, 52, all the packets will again send to the server in the most trivial kind of implementation, right? So that is how the transport layer will provide reliability of data, and it will help me deliver my packets in the same order on the server end, right? Next comes the IP layer or the network layer. Okay, what does it do? It basically provides me routing. Okay, so we talk about like routers and link layer switches will come under in the network layer. Router, before router, like all what is happening will come under network layer. So it will help me provide the routing, like it will help me find out the route, the best possible route to the destination server, right? Next comes a link layer. So what link layer will do? Link layer will basically help me forward the packets from one router to another, or basically not link layer switches, right? So it will help me forwarding the packets. Forwarding the packet as in router to router or router to switch. In this case, it's a link layer switch. Okay, there are two kinds of switches: network layer switch and link layer switch. So don't get confused in the switch. It's a physical device only, but it's of two different kinds. And the last one is the physical layer, and it will help me do the signal transmission. Okay, So that's how we have differentiated and described our TCP/IP model. Like this is the best I could come up with in order to make you guys understand about TCP/IP model. There is another such model which exists, which is the OSI model, right? In OSI model, I think there are two different layers which add up, which is session layer and presentation layer. Okay, more or less they are part of link layer, somewhere between link layer and network layer only, but TCP/IP is the most adopted model right now. One more thing here is this model is very much flexible, right? You can actually tweak any of the layers and you can probably add some more data there, right? So this model is very much flexible and that's why it is widely adopted right now. Okay, so a lot of application uses TCP/IP model, and in fact, like all the web surfing is happening over TCP/IP only in these days, right? So yeah, I think it would clear up a lot of networking concepts today. We have just covered the basic networking in this session of how does the packet transfer. We still have to go into depth about each of these layers, like application servers. There are multiple applications which run HTTP, SMTP, FTP, and on the transport network layer also there are multiple other things which runs. Okay, so we'll go into advanced in later sessions, but for today I think it will create a very good basic for us in order to understand the networking. Right? Thank you.